I want to introduce you to a friend of mine. His name is Melvin. He's a parrot. He's so brave and curious. Melvin has this goal to get from the Earth's surface way out here where he's eventually free from the Earth's gravitational pull. And he came to me and he wondered, well, how fast do I need to flap my wings? How fast do I need to move in order to get out there? What Melvin was asking about is his escape velocity. How fast does he need to leave the Earth's surface in order to no longer be affected by the Earth's gravitational potential energy? So we talked about it, and we figured out that Melvin eventually will have to travel 7 million miles per second in order to escape the Earth, but let me show you how we got there. Remember from the last video, we came up with this expression and we said that this is negative. The gravitational potential energy between two objects should be negative to make sense to us and to follow convention. You could think of it this way. Once a mass is near a large body, it's trapped until something can provide enough energy to allow it to escape. So to escape, you need to have that much energy. And the assumptions I'm going to make here is that when Melvin is way out here, he no longer has any kinetic energy. Obviously, we could tweak this problem in such a way where, yes, maybe Melvin is still moving forward, but I want to look at the particular instance, the minimum velocity needed to get off the surface of the Earth out to this point where you have no more kinetic energy. So here's our lull diagram of this of Melvin. I first was looking at me. How rude of me. We're not looking at me anymore. We're looking at Melvin. Earth and Melvin. At the initial scenario, he's going to fly off the Earth with some kinetic energy, and he also has some potential energy just from being on the surface, and we said this is negative. So this is a new way of describing potential energy that is a universal gravitational potential energy, putting the negative sign here, calling this position way out here to be 0. And when he finally gets there, well, he has no energy. He stopped. There's no more potential energy from the Earth. Obviously, there's no spring, and we're saying that there's no change in internal energy. So our energy initial should equal our energy final, Ki plus UGI, but oh wait, this is a negative, so I plug in my expressions for both of those energies, and I can manipulate the algebra here. Be careful about what your M stand for. In, I guess, over here, the gravitational potential energy, one of the masses is the mass of the Earth, the other mass is the mass of Melvin. Gotta change this too. Mass of Melvin. And you should see that the mass of Melvin cancels out of the equation. So if I want to figure out the velocity that Melvin needs to travel, we can solve it and rearrange the expressions so that we get that velocity. Notice that the velocity only depends on the mass of the Earth and the radius of the Earth. This big G is the constant. So Melvin could be 3 times, 4 times, 5 times as big. It wouldn't matter. He would still need to travel at the same velocity to get off the surface of the Earth. And if you plug in all those variables, the mass of the Earth and the radius of the Earth, you get a value, you convert it to miles per hour and then miles per second, of 7 miles per second. So Melvin has to travel this speed in order to be free of the Earth's gravitational potential. And that's what he's after. Maybe one day he will do it. Hope you learned some cool physics. See you soon. Bye.